Recall the 4 types of transformations: translation, reflection, rotation, and dilation. Today we will be talking about doing dilations. A dilation is when you resize an object by making it bigger or smaller. Recall this example from the Identifying Transformations video. We will talk about the specifics of doing a dilation today.
All right, so let's talk about how to do dilations. Before we get started with that, let's just go ahead and talk about some random stuff that has to deal with dilations that is important to know. So a dilation is a transformation that produces an image, which is the new figure, that is the same shape as the original but is a different size, which is essentially the definition also of a similar figure. Same shape, different size. Dilations can be enlargements or reductions. If it's an enlargement, it's going to stretch and get bigger. If it's a reduction, it's going to shrink and get smaller. To do a dilation, we do apply scale factors to the pre-image, which is the original figure, and that creates our new figure, which is known as the image. The process to do a dilation is we are going to multiply the points in the pre-image, the original points, by the scale factor, and this will create our new figure. You can find the scale factor by dividing a side length in the image, which is the new figure, by the corresponding side in the pre-image, which is the original figure. Scale factors that are bigger than 1 will result in an enlargement, getting bigger, and scale factors that are smaller than 1 but greater than 0 will result in reductions, which is getting smaller. So the rule for dilation is if the center of dilation is the origin, which are the only dilations we are going to do, and the scale factor is defined as the variable k, then you will take x comma y, your original point, and you will do k times x, which is just where you multiply x by k, and then k times y, which is just where you multiply y by k. And that will give you your new points. You will plot those, all the points plotted together, connect them, and that will give you your new shape. So let's go ahead and look at some examples.
So we want to graph the image of the figure using the transformation given. So example 1 wants us to do a dilation of 2. So our scale factor, k, is equal to 2. And it does say about the origin. So what that means is we are going to take our original x comma y, and we are going to do 2 times x comma 2 times y. That is the rule we will apply here to get our new points. So let's go ahead and define our original t, u, and v. Point t is the point -1, 1. U is the point 2, 2. And v is the point 0, -1. So the next step is to apply the rule 2x, 2y, which just tells us to multiply all of these values by 2. So our new t will be -2, 2. Our new u will be 4, 4. And our new v, 0 will stay 0, -2. Now we will go plot these points. Once you have plotted the points, you just need to connect them and you will have your new figure. Here is our new figure. Triangle TUV has been dilated by a scale factor of 2 to form T prime, U prime, V prime. Let's go ahead and look at our second example. Our second example is a dilation of 1/2. So our K, our scale factor, is 1/2, which is less than 1. So we are going to be getting smaller here. We are going to be applying the rule x comma y changes to 1/2 of x comma 1/2 of y. So let's go ahead and define our points and then we can apply our rule. Point P is the point -2, 1. Point Q is the point 0, 4. Point R is the point 3, 1. And point S is the point 1, -3. Now we're going to apply a rule. Our rule says to multiply by 1/2, which is just taking half of a number, which is the same thing as dividing by 2. So our new point P will become -1 and then 0.5, which is a half. Our new Q, 0 will stay 0. Half of 0 is just still 0. 2. Our new R will be 1.5, comma 0.5. And then our new S will become 0.5, comma -1.5. So now we're going to go plot these points. So notice the new P is -1, 0.5. So I'm going to go left 1 and then up just 1/2 of a unit. Q is 0, 2, the new Q. The new R is 1.5. So I'm going to go right 1.5 and then 0.5, so up a half of unit. And then the new S is 0.5, so I'm going to go right 0.5. And then -1.5, so I'm going to go down 1.5. There's my new points. Now I just need to connect them. And this figure should have sides that are half the length of the original figure. Let's go on to our last two types of examples. So these want us to actually write a rule to describe the transformation. So to describe a transformation, the main thing that we need is the scale factor. So I need to figure out how many times bigger or how many times smaller is the figure getting. Now, one key thing that I will tell you to look for is horizontal or vertical side links. If you can find a pair of horizontal or vertical side links, this will be a pretty simple, easy problem. So let's go ahead and look at number 3. So notice that the black figure is the smaller one and it does not have proms. Notice that the blue figure, which is the bigger one, does have proms. So since the original, the black one, is smaller, this means to the new figure it's getting bigger. So our scale factor should represent a dilation that is getting bigger. So I'm going to start with side GH here. So this is just 1 unit, one unit tall. Now G prime H prime is 2 units tall. So similar to what we did in the previous lesson, we're going to take a measure of our new figure, the one with the proms, in this case would be 2, and we're going to divide it by the corresponding measure from the original figure, which was 1. Well, 2 divided by 1 is 2, so our rule is a dilation of 2 about the origin. We know it's about the origin because I told you that's all we're going to do in this class, so really no need to worry about that part. You'll just have to have it written out. All right, let's go ahead and look at number 4. So before we get started talking about a strategy here, I first want to just talk about whether it's getting bigger or smaller. So the black one will be our original figure, and the blue one, notice it has the proms, is our new figure. So if we look at what's happening from the black to the blue, we actually notice that it is getting smaller. So since it is getting smaller, your scale factor will need to be between 0 and 1. So let's talk about a strategy. So on the last one, we had multiple vertical and horizontal side links that we actually could have used to match up a pair of sides. On this one, all of our side links are diagonal. To do this with the diagonal links, similar to the last one, we would actually have to use the distance formula, and that's way more work than I think we need to put into this problem. So let's talk about a slightly different strategy that we can use to do this problem. So instead of finding lengths of the shape, we're actually just going to look at point values. So you can pick any set of points that you want as long as it's Q and Q prime, R and R prime, S and S prime, T and T prime, as long as it's a pair. So I really always like to choose integer values for points if I can, if that's a possibility. So I really want to stay away from S and T just because I can see that those are decimal values. So I would either want to pick R and R prime or Q and Q prime. So I'm just going to pick Q and Q prime, really for no reason other than, again, they're integer values. So the point Q, I'm going to define that, is the point 0, negative 2. Point Q prime is the point 0, negative 1. Now remember, when we do not have a prime, that is a point from the pre-image or the original figure. When we do have a prime, that is a point from the new figure or the image. So what we're actually going to do here is, instead of dividing side lengths like we did on the previous problem when we had like the vertical and the horizontal side lengths, we're actually going to take values from our point and we're going to divide those. Now we can't really use 0 and 0 because there's really no way to tell what the change was there, because 0 is just going to stay 0 no matter what you multiply it by. So we're going to need to divide these. Now recall that this figure from the original to the new one is getting smaller. Well, regardless of whether it's getting bigger or smaller, you are always going to divide a side length or a point value from the image by a side length or a point value from the pre-image. So here, the point value from our image was negative 1, and the point value, the corresponding point value from our pre-image was negative 2. So now we have a fraction that we need to simplify. So a negative divided by a negative cancels, and that leaves us with 1/2, or you could write it as 0.5. Regardless, this is a dilation of 1/2 about the origin. Thanks for watching this video. You now need to go complete the dilations homework on Edge Elastic. Once you have finished with that and finished with the similar figures homework assignment, you need to take the similar figures and dilations assessment on Edge Elastic. Remember, if you have any questions, please do not hesitate to ask me.